process can sometimes look a bit daunting, especially when there are lots of different compounds and state symbols involved. But fear not, to help in this lesson about chemical equations. Quite simply, a chemical equation shows the overall chemical change of reactants into products. It's a bit like a detailed cooking recipe, but where all the ingredients and all the products are written down, even the ones you can't necessarily see. The reactants are what you start with, and the products are what are formed. There are two ways of writing chemical equations: word equations and symbol equations. When they are written, both types show the reactants on the left of an arrow and the products on the right. The arrow is there to show that the reaction is irreversible. If you like, it shows the direction of the reaction and that it is one way. A bit like a one-way street. You can't reverse along a one-way street, and you can't reverse an irreversible reaction. Let's look at a word equation. This is a way of summarising a chemical reaction. For example, the neutralisation of hydrochloric acid with sodium hydroxide. We would write sodium hydroxide plus hydrochloric acid, then the arrow, sodium chloride plus water. The plus sign indicates that there is more than one reactant or product on each side of the equation, and you'll note that the reactants are on the left and the products are on the right. We've also written this all on a single line. It makes it a lot easier to read this way. So when you write your equations, try to keep all of the information on a single line. If you can't, then the arrow becomes an important separator. The rule of reactants on the left and products on the right still applies, because if not, the equation can become a jumbled mess. A clearly written equation is always easier to understand. A word equation provides a good summary, but a symbol equation provides more information. It shows more detail and allows us to see how many atoms and molecules are involved in each reaction. So if we look at the neutralization equation again, the symbol equation is written NaOH plus HCl as the reactants, then an arrow to indicate the irreversible reaction, which gives NaCl plus H2O as the products. The little letters in brackets are state symbols. They show the state of matter of each product and reactant, and this is covered in more detail in our lesson, State Symbols in Chemical Equations. There are occasions where a reaction is reversible due to the changes in the surroundings, for example pressure, concentration, pH and temperature. And where this is the case, we draw a double arrow made of two half arrows pointing in opposite directions. And this indicates that the reaction can go either way. The formation of ammonia from nitrogen and hydrogen is an example of a reversible reaction. And the key thing here is that you recognise the reversible reaction by the double arrows. And you'll note some numbers in front of the hydrogen and ammonia formulae, and these are there to make the equation balance. You can find out more about this in our balancing equations lesson. And so to summarise, a chemical equation shows the overall chemical change of reactants into products. We usually write reactants on the left of the arrow and products on the right. A single arrow means that the reaction is irreversible, and two oppositely pointing half arrows means the reaction is reversible. And that completes our overview of chemical equations.